Toyota has sparked an automotive revolution that is shaking up the entire electric vehicle industry. With the introduction of their new engine, the landscape of EVs may never be the same. According to Toyota's CEO, this engine could disrupt the entire EV market. Unlike current electric vehicle engines, Toyota has developed something completely different. But does this signal one of the most significant shifts in the automotive world? Let's dive in and find out. Before we explore what Toyota's CEO has revealed, let's take a moment to understand their journey. Toyota has long been a leader in the fast-paced automotive industry, and now they're making one of their boldest claims yet, leaving the EV world buzzing with anticipation. Imagine an engine so groundbreaking that even the most devoted car enthusiasts are left speechless. This new engine is truly a game-changer. Recently, Toyota announced the development of a hydrogen combustion engine. However, this isn't just any hydrogen engine, it's a complete departure from the all-electric trend that many manufacturers are following. Toyota has developed a brand new technology, one that we've never seen before. As the name suggests, this hydrogen combustion engine uses hydrogen as its primary fuel. Unlike conventional engines that release carbon dioxide, this engine emits only water from its exhaust, making it a revolutionary step in reducing the global carbon footprint. So how does this engine work? Instead of following the electric vehicle trend, Toyota has chosen hydrogen combustion to reduce emissions. Hydrogen, the most abundant element in the universe, has the highest specific energy density of any non-nuclear fuel. When used as fuel, hydrogen is exhaust-free and non-toxic, with water being its only byproduct. Hydrogen can be produced from various sources, stored for long periods, and easily transported. In fact, millions of tons of hydrogen are produced and used safely each year in power plants, electric vehicles, forklifts, ships, and even trains. The Toyota hydrogen combustion engine operates with a fuel cell that converts hydrogen into electricity. Take the Toyota Corolla Cross H2 concept car as an example. It features a 1.6-liter turbocharged, 3-cylinder engine that runs entirely on hydrogen. This is where Toyota's revolution began, signaling a major transformation in the EV industry. But how does Toyota make this hydrogen technology work? Their vehicles use reinforced fuel tanks to store highly flammable hydrogen, a design inspired by their FCEV, the Mirai. Despite being compact, the Corolla Cross H2 concept car can hold 5 kilograms of hydrogen, allowing for a driving range of around 300 miles. And as for its byproduct? It produces just 50 liters of water, which, unlike carbon dioxide, is not harmful to the environment. To further advance this concept, Toyota has teamed up with Yamaha Motor to develop a V8 engine powered entirely by hydrogen. This collaboration is pushing the boundaries of what's possible in the automotive world, making it clear that the future of EVs may look very different, thanks to Toyota's groundbreaking innovation. This engine is remarkably powerful, delivering around 455 horsepower and 398 pound-feet of torque. To give it a unique edge, Toyota added an 8-to-1 top-mounted exhaust manifold, creating a distinct high-frequency sound. When comparing Toyota's hydrogen combustion engine to other electric vehicles, it has several key advantages. One of the main benefits is its longer range and the incredibly fast refueling, almost like a drag race. This also reduces the reliance on materials like lithium and nickel, which are crucial for manufacturing EV batteries but are in limited supply. Although the car uses a battery to store some power, it's significantly smaller than those in traditional EVs. As of the last quarter of 2023, the Toyota Corolla Cross H2 concept car was undergoing real-world testing in northern Japan, including evaluations in winter road conditions. So far, the reviews have been overwhelmingly positive. Toyota's new hydrogen combustion engine stands out as a true game-changer in the automotive industry, one of the most environmentally friendly engines, producing only water as a byproduct. It also boasts a longer range, faster refueling times, and reduces the need for scarce materials. We are still waiting on the final results from the real-world tests, but it won't be long before these cars hit the roads. If this hydrogen-powered engine is successful, the Japanese government plans to have around 200,000 fuel cell-powered vehicles on the road by 2025, with a goal of increasing that number to 800,000 by 2030. To support this, they'll need to build more hydrogen refueling stations across the country. While the hydrogen combustion engine has already shown it's unlike any other, let's dive into its pros and cons. First, the most obvious advantage is its eco-friendly nature. Since it uses hydrogen as fuel, it doesn't produce harmful byproducts, just water. Hydrogen itself is a much cleaner fuel compared to traditional gasoline. Another benefit is the engine's highly effective cooling system. The water cooling feature tackles one of the biggest challenges engines face: overheating. This system could significantly improve the engine's performance and longevity, making overheating issues rare for drivers, which is a huge plus. Additionally, the technology behind this engine is quite familiar. It operates similarly to traditional engines, making it easier to integrate into existing automotive designs and manufacturing processes. For Toyota, this means they can adapt their other vehicles to incorporate this engine, which is a significant advantage. However, as with any innovation, there are drawbacks. The first challenge is the production and infrastructure for hydrogen. While the engine is eco-friendly, its sustainability depends heavily on how the hydrogen itself is produced. Currently, hydrogen production, though widespread, isn't always sustainable. If these cars are to be mass-produced, automakers will need to address this issue. Moreover, the infrastructure for hydrogen fueling is still lacking. Since hydrogen-powered cars are not yet common, there are far fewer hydrogen fueling stations compared to gasoline or electric charging stations. This presents a major hurdle in the widespread adoption of hydrogen vehicles. One of the key challenges with hydrogen combustion engines is their complexity and cost. While these engines share a similar architecture with conventional engines, they incorporate a dual water injection system. This, combined with the need for precise ECU control, makes the system more complex. Increased complexity naturally drives up manufacturing costs, and owners may also face higher maintenance expenses since the parts are less common. Even if Toyota were to achieve large-scale production, they would still need to address market readiness. As of now, the production-ready version of the engine is still under development and testing. Even when it's ready, it will take time before the vehicle becomes commercially available. Toyota's development of the hydrogen combustion engine reflects its commitment to exploring multiple sustainable transportation solutions. Alongside their electric and hybrid engines, this new technology showcases Toyota's interest in diversifying its eco-friendly vehicle options. While the hydrogen engine promises to shake up the EV industry, how does it differ from traditional internal combustion engines? One of Toyota's standout achievements in this field is the 1.6-liter, 3-cylinder turbo engine, which powers the Corolla Cross hydrogen prototype. This engine perfectly balances traditional design with innovative technology, but it's a marked departure from conventional internal combustion engines. The 1.6-liter engine, based on the platform of the high-performance GR Yaris, has undergone significant modifications to support hydrogen as a fuel source. This led many to wonder, how did Toyota manage to maintain the engine's performance while switching to an entirely different fuel? The answer lies in the hydrogen combustion process. Hydrogen requires different handling and combustion techniques compared to gasoline, and Toyota has equipped the engine with a high-pressure hydrogen direct injection system. This allows precise control of hydrogen delivery into the combustion chamber, optimizing both performance and efficiency. Despite these differences, the engine's overall performance is impressive. The 1.6-liter engine generates enough power and torque to compete with gasoline engines, thanks in large part to the turbocharger, which ensures the engine delivers the necessary boost for high-performance driving. However, concerns have been raised about whether turbocharging is the best approach for handling hydrogen's unique properties. Hydrogen has a lower density than gasoline, meaning the engine requires a larger volume of hydrogen to produce the same energy output. Toyota's engineers have faced this challenge head-on, optimizing the turbocharger and other engine components to handle hydrogen's distinct characteristics effectively. One of the standout features of this engine is its remarkable efficiency. In fact, hydrogen combustion engines are significantly more efficient than traditional engines, particularly during high-load situations. This increased efficiency not only improves fuel economy but also has a positive environmental impact. With better fuel economy, the engine requires less fuel, and most importantly, emissions are drastically reduced. The only byproduct of the combustion process is water vapor, meaning these engines produce near-zero emissions. This positions it as one of the most environmentally friendly options available. Achieving near-zero emissions is crucial for Toyota as it aligns with their carbon neutrality campaign. Toyota is taking a multidimensional approach to carbon neutrality, integrating both hydrogen and electric technologies into their strategy. While they could have opted for a singular focus on one technology, they chose a diversified path to better meet global needs. But why focus on hydrogen? Hydrogen's potential as a clean energy source is compelling. Whether used in fuel cells or internal combustion engines, hydrogen only emits water vapor, making it a highly eco-friendly alternative to fossil fuels. However, Toyota's investment in hydrogen extends beyond passenger vehicles. They've incorporated hydrogen technology into commercial vehicles and public transportation systems. Yet, hydrogen alone isn't enough to achieve full carbon neutrality, and Toyota acknowledges this. They have also embraced electric vehicle (EV) technology. Unlike other automakers who focus solely on EVs, Toyota recognizes the challenges facing the widespread adoption of electric vehicles, such as limited driving range, long charging times, and the environmental impact of battery production and disposal. To address these issues, Toyota offers a variety of powertrain options, including hydrogen fuel cell vehicles, plug-in hybrid electric vehicles, and battery electric vehicles, BEVs. By offering these diverse powertrains, Toyota aims to cater to a broader range of customer needs and driving conditions, all while advancing toward their goal of carbon neutrality. Toyota's approach also takes into account the varying energy sources, infrastructure, and environmental policies in different regions. For example, in areas that rely heavily on renewable energy, BEVs may be the best option. In regions where hydrogen production is powered by renewable sources, hydrogen fuel cell electric vehicles, (HEVs), and hydrogen internal combustion engines, HYCEs, could be more suitable. Toyota's commitment to carbon neutrality goes beyond vehicle emissions. The company is actively involved in reducing the carbon footprint of its manufacturing processes by promoting recycling, resource efficiency, and investing in renewable energy projects. However, there is still much work to be done to reach their ambitious goal of full carbon neutrality. To fully grasp the impact of Toyota's strategy, it's crucial to take a step back and see the bigger picture. Achieving a carbon-neutral society requires significant changes, not only in vehicle technology but also in how energy is produced. Toyota's multi-technology approach, combined with its broader sustainability initiatives, reflects a comprehensive effort to tackle these challenges head-on. Beyond working towards carbon neutrality, Toyota's strategy offers environmental benefits that may be more significant than you'd expect. As the automotive industry transitions to sustainable energy, Toyota's hydrogen-powered internal combustion engines present a compelling option. But how do these hydrogen engines compare to hybrid electric vehicles, HEVs, and plug-in hybrid electric vehicles, PHEVs? The key difference lies in their environmental impact, particularly the emissions profile. Traditional gasoline engines emit substantial amounts of carbon dioxide, CO2, a major contributor to global warming. In contrast, Toyota's hydrogen engines produce zero CO2 emissions during operation. For skeptics who believe zero emissions are impossible, hydrogen combustion proves otherwise. When hydrogen burns in these engines, it reacts with oxygen to produce energy, and the only byproduct is water vapor, H2O. This elimination of CO2 emissions is a major step towards reducing the automotive industry's carbon footprint. Now, let's compare this to HEVs and PHEVs. HEVs combine a gasoline engine with an electric motor, while PHEVs can be plugged in to charge their batteries. Both offer improved fuel efficiency and reduced emissions compared to gasoline-only vehicles. However, they still rely on gasoline, meaning they continue to emit CO2, albeit in lower amounts. Hydrogen engines, on the other hand, offer the potential for true zero-emission driving, provided the hydrogen fuel is sourced sustainably. Another factor to consider is the life cycle emissions of these vehicles. HEVs and PHEVs require batteries made from rare earth elements, and the energy-intensive processes involved in producing these batteries contribute to higher carbon emissions. Hydrogen engines avoid many of these issues. When hydrogen is produced from renewable sources like wind or solar power, its environmental impact is far lower than that of battery production, making it a more sustainable option in the long run. Moreover, hydrogen combustion engines are more efficient than traditional combustion engines, especially in heavy-duty applications. In fact, their efficiency can rival that of hydrogen fuel cells, further underscoring their potential in sustainable transportation. Fuel cells are known for their high efficiency, especially at low loads, but this efficiency tends to drop when operating under higher loads. On the other hand, hydrogen combustion engines reach their peak performance under high loads, making them ideal for applications that demand high performance. As the world battles the challenges of climate change and resource depletion, technologies like Toyota's hydrogen engines offer a glimmer of hope. These engines promise cleaner, greener transportation without sacrificing performance or practicality. Speaking of performance, hydrogen engines are said to deliver similar results to gasoline engines. But how is this achieved? The secret lies in the nature of hydrogen as a fuel. When compared to gasoline, hydrogen burns faster, resulting in a quicker engine response, an essential factor for high-performance driving. But how does this affect the driving experience? Drivers accustomed to conventional internal combustion engines expect immediate throttle response and a powerful engine growl, much like the roar of a Dodge Charger. Surprisingly, hydrogen-powered internal combustion engines, HYCEVs, can replicate these sensations. Despite using clean fuel, Toyota's hydrogen-powered cars maintain the familiar sounds and feel of traditional engines, an integral part of the driving experience for many enthusiasts. Performance-wise, Toyota put its hydrogen engine to the ultimate test in the world of motorsports. When they introduced a hydrogen-powered vehicle into a racing series, it demonstrated both the durability and potential of this technology for high-performance applications. These HyCEVs performed on par with traditional gasoline-powered cars, matching them in speed, agility, and endurance. In fact, hydrogen engines can deliver horsepower and torque comparable to gasoline engines, and in some cases, even surpass them. This is a significant milestone, proving that hydrogen can serve as a viable alternative fuel for high-performance vehicles. One question often asked is whether these hydrogen-powered cars can provide the same driving pleasure as their petrol counterparts. Although subjective, early indications suggest that they can. Drivers who have tested Toyota's hydrogen-powered vehicles report a familiar yet exhilarating experience. The combination of traditional internal combustion engine dynamics with the novelty of clean fuel technology is bridging the gap between current automotive standards and the future of green transportation. Whether for daily commutes or the excitement of the racetrack, HyCEVs are poised to deliver the same performance and enjoyment that drivers love, all while paving the way for environmentally conscious driving. Beyond hydrogen combustion engines, Toyota is exploring even more revolutionary technology, a water-powered engine. If realized, this technology could disrupt the electric vehicle (EV) industry entirely. Imagine an engine that runs on water. Although it sounds like science fiction, Toyota is taking steps to make this a reality. The concept revolves around extracting hydrogen from water through a process called electrolysis, which breaks water down into its hydrogen and oxygen components. Hydrogen, a high-energy fuel, could then be combusted to run an engine, producing water as the only byproduct, zero carbon emissions. This water-powered engine would represent a significant leap toward sustainable transportation. Toyota has already filed patents related to this technology, signaling their commitment to making it a reality. However, integrating this system into practical automotive applications presents challenges, such as creating an efficient electrolysis process and designing engines capable of handling hydrogen combustion. Yet, given Toyota's track record of innovation, these challenges seem conquerable. Toyota has already shaken the EV industry with its hydrogen combustion engines, but if the water-powered engine comes to fruition, it will change the industry forever. Thank you for watching, and I'll see you in the next one.